Welcome to aminacademy.com. In mathematical formulae and their explanation, let us discuss about a complex numbers. A complex number is an element of a number system that extends the real numbers with a specific elements denoted I, called the imaginary unit and satisfying the equation. Every complex number can be expressed in the form of A and B or real numbers. Here z equal to a plus ib, where a is the real part of the complex number and ib is the imaginary part of the complex number. Here I is square root of -1. This is the definition of I. Now next one, definition involving a complex number. Z, a complex number, is equal a plus bi. Here where a is the real part, b is the bi is the imaginary part, and conjugate of complex number. Conjugate conjugate of z is complex number is z bar, which is equal a minus bi. So a plus bi is z and z bar, that is complex conjugate of z is z bar is a minus bi. Equality of complex number. Here, if the complex number a plus bi is equal to c plus di, then we can say if a equal to c and equal to b. That means if a is equal to c, real part is equal for both complex number and imaginary part is equal for that complex number, then we can say both complex numbers are equal. Arithmetics of complex number. We will discuss about arithmetics of complex number. First, addition. A plus bi plus c plus di can be written as the real parts are added separate, a plus c, then imaginary parts is added. This is the addition of the complex number. Subtraction is a plus bi subtracted c plus bi, which is equal a minus e, the real part, and b minus d is the imaginary part, b minus d into I. Next is multiplication of complex number, a plus bi, c plus di, which is equal ac minus bd plus ad plus bc I. Next one, division. A plus bi over c plus di is equal to, first you write a plus bi over c plus di and rationalizing the denominator, that multiply upon down by c minus di. C minus di over c minus di, which gives the real part is ac plus bd over c square plus d square. This is a real part. That imaginary part is bc minus ad over c square plus d square I. Next one, complex plan. Here, complex plan means a complex plan is the plan formed by the complex numbers with a Cartesian coordinate system, right? Such that the horizontal x-axis called the real axis is formed by the real numbers and the vertical axis y-axis called the imaginary axis is formed by the imaginary numbers. This y-axis is formed by imaginary number, x-axis is formed in real numbers. Next one, polar form of a complex number. A polar form of a complex number z equal to x plus iy with coordinate x comma y is given as r cos theta plus I r sin theta, which is equal to r into cos theta plus I sin theta. The abbreviated polar form of the complex number z equal to r cis theta, means r into cos theta plus I sin theta, where r equal to square root of x square plus y square and theta equal tan inverse y over x. Here, this suppose in a complex plan, z is a complex number, z equal to a plus bi. Then from the origin to that point is r, radius, and b is vertical distance, a is horizontal distance of that point z. Then we can say in complex form, this complex number is r cis z equal to r cis theta and theta equal to tan inverse y over x. This is a polar form of the complex numbers. Next one, the multiplication and division of complex number in polar form. Here, let the complex number z equal x plus iy, which can be written in polar form r equal cos theta plus I sin theta. Is a polar form. We often call r equal modulus of z equal square root of x square plus y square. Then this is a polar form of a complex number. Then multiplication and division of this complex number, we can say first r1, the first complex number, that is r1 into cos theta 1 plus I sin theta 1 into r2 cos theta 2 plus I sin theta 2, which is equal, simplified form, right, r1 r2 cos of theta 1 plus theta 2 plus I sin theta 1 plus theta 2. For same division, we can write r1 cos theta 1 plus I sin theta 1 over r2 cos theta 2 plus I sin theta 2 can be expressed in polar form by using De Moivre's theorem. r1 by r2 into cos theta 1 minus theta 2 plus I sin theta 1 minus theta 2. Next is, what is De Moivre's theorem? According to the theorem of De Moivre, the power of complex number expressed in polar form is equal to the same power that is obtained by increasing the modulus to the same power and multiplying the argument by the same power. That means De Moivre's theorem tells like cos theta plus I sin theta whole power n is equal cos n theta plus I sin n theta, which is represented by e power I theta power n equal e power I n theta. Then we can write in this form also. Look at here. R into cos theta plus I sin theta power P, which is equal R power P cos P theta plus I sin P theta. That means here by De Moivre's theorem, R of cos theta plus I sin theta can be written as R power P into cos P theta plus I sin P theta. Roots of complex numbers. Now, let us discuss about roots of complex numbers. Suppose P of power n is R and R phi equal to theta plus 2k pi, where k equal to element of z. Then root, that is P is equal or rho equal R power reciprocal of n 1 over n, R power n 1 over n, and psi equal theta plus 2k pi over n, periodicity of the psi equal to where k is element of z. Therefore, the values of omega are the roots of the complex number. We can write in general form R power 1 over n into cos of theta plus 2k pi over n and plus I sin theta plus 2k pi over n. This is the roots of complex number. From this, we can find any root of nth root of the given complex number. Next one, nth root of unity. What is nth root of unity? The nth root of unity can be found below. We know that the nth root of unity is denoted as z power n equal to 1, where n is the positive integer and is then nth root of the unity. If you rewrite this above equation in polar form, that is z n equal to cos theta plus I sin theta. From the above, we know that nth root of the complex number can be denoted as z power n. Z power n is cos theta plus 2k pi plus I sin theta plus sin 2k pi and Zn equal cos of theta plus 2k pi plus I theta plus sin 2k pi, where k is an integer. From this formula, taking nth root on both sides, we can get Zn z equal to 1 power n, 1 over n, power 1 over n, where cos 2k pi plus I sin 2k pi. K, if you substitute, second root means 2 you have to substitute, third root means 3 you have to substitute like. So we can get the final results for nth root of unity. Look at this figure. This here, suppose this up to this here, omega equal to theta over theta equal to 2 pi by n. If you substitute n value, we can get that nth root of that unity. So far we discussed about the formulas of complex number and its type, arithmetics, operation of complex number, and roots of the complex number, and De Moivre's theorem we explained. We have done. Please subscribe our YouTube channel.